In this session, we'll be talking about how do we create different kinds of sequences in R. So in some cases, I may have to generate some kind of a serial number, right? Or in some cases, I may have to create numbers from X to Y. So what are in some cases, I may have to create alternate numbers, 1, 3, 5, so on. So how do we generate different kinds of sequences? Now, especially when we are talking about creating vectors. Vector is nothing but one dimensional array of numbers, right? And if I have to create vectors, one of the ways is I generate a sequence of numbers. And the simple way of generating that sequence is I can use a colon, something like this. Right? If I'm using 0 colon 10, you see it has generated numbers from 0 to 10. Or probably I say 10 colon 0. It will do in the reverse order also. Or probably I say 10 colon 18. So either it would be an increment of 1 or it could be a reduction of 1. That is a very default way of generating the sequence. The increment or the reduction is in steps of 1. So I just need to specify the first value and the last value, and they are separated by colon. But if I want increments not of 1 but by 2 or something else, in that case we use this kind of a mechanism. We use sequence from, to, and by how much. So I'll say SEQ sequence 10, 20, 30, 2. It means that you create a sequence of numbers from 10 to 30 with an increment of 2. So we get the numbers 10, 12, 14, 16, 18. Right? It could be even sequence 30 to 10. If I'm giving it in the opposite, in the decreasing order, then my decrease should be negative. So I'll give it as minus 2. But if I give it as 2, in that case, just check this. 30, 10 and 2. It can't, because it can't go from 30 to 10 with an increment of 2. Right? So that's where we have to define it properly. Depending on whether we are increasing the number or decreasing it, we will add the increment either positive or negative. That's one more way of generating a sequence, especially if my increment or decrease is not by a factor of, is not by 1, plus or minus 1. Now, there are different ways. Let's say in some cases, I want to generate a sequence that is matching one of my vectors. So let's say I already have a vector x which is taking the values something, right? 2, 5, 6, 7, 3, 6, 8, whatever. So let's say this is my sequence. Now I want to create one sequence which is matching in length with this. So let's say I want to create a sequence y, right? I want to create one sequence y. Again, let's call it increment from something to something. So I'll create an sequence from 10 to I'll create a sequence starting from 10. I can use one of this kind of a mechanism, from, by and the length. 3 things. So what I'll do, I'll say from 10. From equal to 10. Then by how much you need to increment? I want to increment by 5. and the length. How much? This time I'll count how many are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I want to increment this 10 times. So that is what I am assigning to y, and if I am checking what the y is, these are the numbers 10, 15, 20, 25, 30, 35, 50, 55. But in this case, what has happened? The length equal to 10, I physically went ahead and did the counting. But if I want to avoid that, the other alternative is, instead of using the length function, length is typically when I know the length. But if I don't know the length and I have to explicitly count it, it's better to use along that particular vector. So what I can simply say here, now I'll give a new y where I am doing a sequence from equal to 20 by equal to 10. So I am incrementing it by 10. But this time I am saying along equal to x. So go along, get the size of x, and based on that create your y. Now if I look at y, this time it creates from 20 by an increment of 10, and it itself computes what is the value of the length of x, and based on that creates a vector here. So that is how we take from, by, along. Sometimes I won't give by, but I give from and to along with along. So the system will compute what is the by. So if I say sequence from equal to 10 to equal to 50, and if I say along equal to x, now it has computed what should be the increment. So it's moving from 10, 14.4, 18.88, 23.33, because it has computed the sequence based on your from and to and along, which is talking of what all, how many values are there with respect to x. So these are different ways in which we generate the sequences. And let's say in some cases we are generating a sequence, right? Let's say the basic sequence itself, or any of these sequences. Let's say we are talking of generating a sequence from 10 to 20 with an increment of 3. Now 20 doesn't come, so when you are incrementing 10, it becomes 10, 13, 16, 19, 22. But it is crossing, but it's not touching 20. So what happens is, it generates sequence only up to 19, which means the increment is not matching the final value. The increment in this case is not matching the final value. In that case, the sequence stops short of the last value. So whichever 20, so whichever is the value just below 20 and coming in the sequence, that is where the sequence gets stopped, right? So all these things. And in some cases, if I want to generate a sequence like this, means I want to repeat a set of values. So the first thing I want 4 times, 1, 2, 3, 4. Then I want 3, 1, 2, 3. So in that case, I can give, so when I'm using the word full sequence, right? Let's see, if I'm using the word full sequence and I'm saying 5, it means that it is generating a sequence of values right from 1. If you are seeing, it's not a abbreviation. I'm using the full word sequence, and let's say I'm putting 20. It is generating the values right from 1 to 20. So wherever I want a serial number kind of thing to be generated, I can very well use this sequence as a command. Now here, just to improve it, I'm saying sequence of, so if I say 4, 3, 5 or 6, it means that first it will generate a sequence of 4, 1, 2, 3, 4. Next it will generate a sequence of 3, 1, 2, 3. Next, it will generate a sequence of 6 starting from 1. So that's what we are getting as an outcome: 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6. So these are the different, some of the very common ways of generating sequences in R. And at different points in time, we may require to generate these kind of sequences. Once we get into the application part of it, these things become more and more comfortable. But we need to be clear that these are the different ways of creating the sequences. Then, the next aspect that I look at in terms of in the same lines as sequence is the repetitions of something. The first thing, I can repeat one single value multiple times. In that case, I'll simply say rep a value 10, I want it 4 times. So it generates 10, 10, 10, 10. So one single value, if I want to repeat it n number of times, I simply say rep the value comma n number of times. But if I want a series of values to be repeated n number of times, a sequence of values, so I want, let's say, 10 to 15 to be generated 3 times. I want 10 to 15 to be repeated 3 times. So I get 10 to 10, 11, 12, 13, 14, 15. Again 10, 11, 12, 13, 14, 15. So I want it to be repeated 3 times. So that is how my outcome is coming. The same set is getting repeated 3 times. But in that itself, I want each one like 10, 10, 10, 11, 11, 11, 12, 12, 12. If I want that kind of a repetition, then I will simply set each equal to 3. When I set each equal to 3, so if I just put 3, then the whole sequence is repeated. But if I am using the word each equal to 3, then each item of the sequence is typically repeated 3 times. So this is one more way of doing the repeat. Then if I really want each one to repeat n number of times, and after that whole sequence need to be repeated k number of times. So each one needs to be repeated 2 times and the whole sequence need to be repeated 3 times. So if I say each rep 10 to 15, each one needs to be repeated 2 times. So it becomes 10, 10, 11, 11, 12, 12, 13, 13, 14, 14, 15, 15. Now this whole block, I want it to be repeated another 3 times. So now you see what is happening. 10, 10, 11, 11, 12, 12, 13, 13 up to 15, 15. So this is the block. Now this block is repeated 3 times. This is the second time. This is the third time. So if I want internal repeat first, individual repeat, and then I want the block repeat, I can use this kind of a mechanism. So there is one more, this is one more way of generating the repetition values in R. Then I can also look at repeating something different number of times. Each element is repeated different number of times. So let's say I want 1, 2, 3, 4, 1 to 4, and I want them to be repeated 1 to 4 times. So which means 1 has to be repeated once, 2 has to be repeated twice. So I am keeping it like this, or the other way. So let's say I want to repeat, right? I want to repeat 10 to 15, and I want to repeat them. So 10 has to come once and 11 has to come twice, something like this. So wherein the only thing I have to make sure is these two are of equal length. 10, 11, 12, 13, 14, 15. There are 6 numbers. So here also I am making sure that there are 6. So the first one would be repeated as per the first number of times, second one, second number of times, and so on. So here the 10 is repeated once, 11 is repeated twice, 12 is repeated thrice, and so on. Even I can give it the reverse way also. 10 to 15, I can repeat it, let's say 6 to 1. So 10 is repeated 6 times, 11 is repeated 5 times, and so on. Or I can have completely irregular kind of a process. So probably, let's say 10 I want it 4 times, 11 I want it 8 times, 12 I want it once, 13 I want it 5 times, 14 I want it 3 times, and probably the other 15 I want it again, let's say 3 times. So some kind of a irregular process altogether. Even that is very much possible. So 10 will come 4 times, 11 will come 8 times, 12 is coming only once, then 13 is 5 times. So we can generate even sequences of this. So rep is a very strong word which can generate the kind of repetitive terms, create different kinds of sequences for us, following different kinds of pattern. Similarly, I can do the same thing even with the characters also. Right? I say rep. Let me give some names. Let's say Vamsi. Then I'll call it cat, rat. Now these three characters, these three words, I want to repeat 4 times, 2 times, 5 times. So the first one is repeated 4 times, the second one 3 times, and the third one is repeated 5 times. Now this is how we can create not just for numbers, we can create even text kind of sequences as well. So that's one more way of doing the repeat. Then the other important thing is creating a series associated with the factors. Right? I want to create different kinds of factors. This is where the repeats will come in more and more handy. Now, I want to know how many factor levels are there. Right? I want to know how many factor levels are there and how many times they need to be repeated. So GL is a very interesting word, generating the levels. GL is meaning the generation of the levels. I can specify how many factor levels are there, in this case 4, how many times they have to be repeated. So when I say GL 4 comma 3, let me just give it GL 4 comma 3. It means each factor will be repeated. There are 4 factors. Each factor will have 3 repetitions. 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. But it's the same if I am saying, if I am adding a third component, 4 comma 3 comma 24. It means this 4 and 3, there are 4 factors, 3 levels. Sorry, 4 levels, there are 4 levels, 3 times each one is repeating, and like that there are 24 observations, which means this whole pattern has to repeat 2 times. Now if I am saying GL 4 comma 3 comma 20, which is not a multiple, then it will stop only after this repetition will go only up to 20 elements. So basically it means that first there are 4 factors. Each factor has to come 3 times. So 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. And like that, this sequence, this pattern has to continue until 24 elements. So wherever it stops, it stops. But the same pattern of 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4 needs to be repeated. That is what it means. Right? Now, I can even give the naming also. So probably we'll give some factors and some kind of a labels. Okay, we'll give some X as the name of the factor. We'll generate levels, right? We'll generate that there are 2 levels. and 2 times repetition. Let's say we are going up to 24. So there are only 2 levels. Because there are 2 levels, I'll give them the labels. I can give them the labels. I'll give the namings to them, wherein I am putting them under the C. Let's say good and bad. Right? I'm giving them the labels good and bad. Right? So if I'm displaying X, it says good, good, bad, bad, good, good, bad, bad, good, good, bad, bad, and so on. Because there are 2 levels, each repeated 2 times. But at the same time, if I'm putting, let's say Y, again GL, this time I'll create 3 levels, right? And probably 8 repeats. Again, 24 observations means 1 8 times, 2 2 2 2 2 2 2 8 times, 3 3 3 3 3 3 3 again 8 times. Now for these 3 levels, let me put some labels. Let me put some labels: high, medium, and low. Right? I'm putting some labels: high, medium, low. Now if I am displaying Y, I will get that as high, 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 low, medium, 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 and low, 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 low. Now, like this, you can create any number of. So probably we also had 4 levels with 3, or I can create 6 levels. I can create a Z with 6 levels, right? With 6 levels, each repeating 2 times, but again up to 24 values. Because there are 6 levels, I have to give my labels. I'll give my labels as let's say A, B, C, D, E, F, or yeah, I'll give them the labels A, B, C, D, E, and F. Right? So these are the labels that I'm giving, and if I'm looking at Z, A, B, B, C, C, D, D, and there are 6 levels with names A, B, C, D, E, F. And if required, I can even merge all of them into a data frame by pulling. It's like a table kind of a stuff. I can merge all these things into a data frame, giving X as one variable, Y and Z. The only thing is the length of each of the vectors need to be same. And here we have ensured that all of them are 24 in length. So I am getting X, Y, Z in a tabular form: good, good, bad, bad, good, 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 and high, 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 A, B, B, C, C, D, D. So this is how we can even generate a sequence if required using the different factor levels. And so GL is a keyword which can help us in generating the factors like this. Right? So these are all different ways of generating the sequences which can really help us in generating the data quite effectively, and probably whatever is the calculation required, it really helps us in going forward with the calculation. Alright, thanks a lot for listening to this session. Any queries, you can very well call me or send me an email. Thank you very much.